Amazing. So, hey everyone, welcome to my talk, Fantastic Swift Tools and Where to Find Them. As Jeroen mentioned, it's not going to be like the movie. It's going to be a bit disappointing, but yeah. So before we get started, my name's Paul. I'm a senior iOS engineer at BBC iPlayer. As Jeroen said, I'm from Barcelona, but I'm based in Manchester. I lived in the UK for the past 8 or 9 years. I love Swift and developer tooling. I do like the compiler side of things and CI and all that sort of stuff. And as a random fact, I love football and I love collecting football shirts. So every time this started as my parents would bring me a t-shirt bag when they used to travel. They used to travel a lot for work. They would bring me a football t-shirt bag, and I kept that tradition. And every time I go somewhere, I haven't bought an Ajax t-shirt, but I'm sure I'll do that at some point. Cool. So just a bit of context about the talk. Over the past few years, since I'm an iOS developer, I try to do as much as possible with Swift. What this means is that any side project that I do, I tend to use like Swift for it first. So you can see on the image, it's quite small, but you can see that I wrote an article earlier this year about scripting with Swift. So I had to write like some Git hooks, and instead of using Bash or Python or any alternative that I wasn't too familiar with, I just wrote it with Swift, because you can. And it was a good experience, so I just wrote about it. I'm going to talk about taking Swift way beyond like iOS and macOS development. So we're going to talk about like some cross-platform stuff, some Vapor stuff. We're going to look at a bunch of things. I'm going to introduce quite a few like interesting Swift tools that I've used and that I've learned along the way. And yeah, hopefully the goal of this talk is to encourage you and inspire you to use Swift more in things that you might not think Swift capable of. There's a lot you can do, with it. So we're going to go from a simple script, similar to that Git hook, but it does a different thing. A simple file that you can execute on your Mac to a full stack application. We're doing it in a single Swift package, so you can basically write all your targets, all your products in a single Swift package, which will act as a monorepo. And yeah, there's going to be code examples for everyone about literally everything. So if I run a bit fast over everything, over anything, you're going to be able to access the code in the repo. It's all open source, so you can take a look, copy code, whatever you want. So why Swift, though, you might think? So Swift is got a strongly typed system. It's a strongly typed language, and it's compiled. So it provides a lot of compiler safety, kind of like guides you through a lot of things and reduces the amount of runtime crashes that you can get. It's got a low memory footprint. There was a study, actually, it was quite interesting, comparing the environmental impact of different programming languages. And it basically took an algorithm and compared it and benchmarked it across different languages. And you can see, at least in this case, Swift ranks quite high, but you can see the alternatives that are usually used for like cross-platform tools, such as TypeScript or JavaScript, even Python, ranking very, very low, even in the like memory footprint. It's got a great developer experience. It's got a degree of familiarity. Like, we're all iOS developers here, so we kind of like, we know about Swift. We work on Swift features every single day, so we're familiar with it. We know how to do a network request. We know how to fetch a file from disk. So we know we don't have to Google the simple tasks. It's got a mature and amazing community, so a lot of these things that I'm going to talk about are driven by the community. And yeah, it's amazing the amount of stuff that people have worked on with Swift. And because this is if there was a book for me writing with other languages, this would be it. It's literally just copying and pasting from Stack Overflow. So every time I have to do something with Bash, it's literally Google o'clock. I just go on Google, find Stack Overflow posts. So yeah, I prefer when I have to do something simple, I know how to do it in Swift, so I just try and do that. So yeah, I'm going to talk about reading time. So reading time is a little like open source tool that I made a while ago to get an estimated reading time for a Markdown file. So Markdown file is what you can see in the image there. It's a text format, basically. It's widely used for like blog posts and stuff like that, and documentation, readmes, all of that is Markdown. So the point of this tool is it's inspired by Medium's reading time feature and a lot of other blogging platforms. And it gathers the number of words in a given document in a string, and it divides it by a constant called words per minute, and then you extract the minutes from there, and you can get an average reading time. It's written entirely in Swift. It's distributed, as I said, as a Swift package, so it's a monorepo with a library, executables, APIs, playgrounds. So it's got all of that, and at the core, it's a Swift library. So everywhere that I'm taking this, there's going to be you're going to execute Swift code. And yeah, I'll take you through how to get it running everywhere that I've done so far just with Swift. So where did it all begin? So it began with creating a simple file. This was called reading time. And to make it executable, I just added the shebang. So what this tells the system is basically when you run it as a Unix executable, it will tell the system that you need to use Swift, and it will pass the contents of that file to the Swift interpreter. So at this point, I could just import Foundation and write Swift. So I did that. I grabbed the command line. I made sure that the command line number of arguments was right. So it's going to be 2 because I mentioned that the system is going to pass the contents of the file to Swift. So I still want the user to pass an extra argument. So I make sure that it's 2. Then I get the second argument, which is the path to the file that the user has passed to the script. And then I do some simple file manager stuff to read the contents of that file, get a string, and then I remove the emojis because I didn't want to count the emojis from for the word count, and then just get the time interval in seconds and print it to the user. So it's very, very simple. We're going to see what it looks like in action. So if I go to the next slide and I just run it, I can make the file executable by changing the permissions on it, adding the executable flag to it, and then just run it on a simple markdown file, hello.md, and it tells me it took 1 minute. It would take 1 minute, 30 seconds to read based on the words that it has. So that's it, right? That's all I wanted to do at the time. I wanted to parse all the markdown files in my blog with this tool, with this script, and just get put those values in the metadata for the markdown files. So could we improve it? Could we make it better? The thing with the script is that it wasn't very scalable, so I couldn't reuse that logic. I couldn't just grab that logic and share it with an iOS application or a macOS application that did kind of the same thing. So I couldn't put some UI around it. It was just a simple script. Only Foundation APIs can be used. There's hacks and third-party things that you can do to get third-party libraries to work in scripts. But if you want the pure Swift scripts, only Foundation APIs can actually be used. And you can see there that there's images and links, and I didn't really want to count the URLs towards the word count because they're not really shown to the user. The user doesn't really read those URLs. So I wanted to do some modifications, and I wanted to use Swift Markdown from Apple, the library, the Swift package, and I wanted to bring it in and do some modifications. So another disadvantage is the system needs to have Swift installed to run the script, which is unfortunate. I didn't want people to have to install Swift to use the script. So I needed a better way to distribute. So what did I do? I created a Swift package, which is what I pretty much do all day now. I just create Swift packages. So yeah, you create a Swift package by doing Swift package init with the type of library, because I wanted to just reuse the logic from that script. And this will create a package.swift. So it will look a bit like this. I made some modifications, but the shell will look exactly like this. So we've got a library, which will be the product initially for this Swift package. Then we've got 2 targets, one which will contain the code for the library, and the other one will be the tests. So as I said, I wanted to use Apple's Swift Markdown library, so now I can do so. So I can bring it in as a package, as you can see there, and then I can add it as a dependency to my reading time library. So now I can write some code. So I created a Swift file called reading time, and my library is probably one of the simplest libraries you will see. It's a public enum with a static function. That's literally all there is to it. And this static function will be called calculate, and you pass it a content, which will be a markdown content. You've got words per minute that you can override, but it defaults to 200. I believe that's what Medium uses. And then you return time interval, which will be in seconds. So first thing to do, as I said, I wrapped Swift Markdown around my own class, so it was a rewriter, so I could remove the link URLs and just keep the titles and remove the images so they wouldn't count towards the word count. And then I do pretty much the same as the script did. So I remove the emojis, didn't want to count them, get the time interval in seconds, and then I just return, instead of formatting the string, I just return a rounded version of it. So that's it, just return some seconds from a Markdown string. But you might be thinking now, you've lost the ability of running it from the command line, right? That was the thing that I was doing at the beginning. So we've taken a step back in a way, but we're going to make it better because we're going to be able to reuse this code now very, very easily. So let's add an executable target. And not only are we going to add an executable target that runs for macOS, it's also going to run for Windows, and it's going to run for Ubuntu as well. So we're going to make it better. We're going to be able to distribute it without having to have Swift installed in any of the systems. So to do so, we go back to our Package.swift. As I said, it's going to be a monorepo, so I'm going to keep adding to the Package.swift. Just think of it as if all the targets are there. I've just removed it because of the presentation, because of the slides, because otherwise they would take up too much space. But the first thing you do is you add an executable target. So this will be called reading time CLI, and it depends on reading time, so we can calculate content from a string very easily. Then we bring in a helper, also made by Apple, we call Swift Argument Parser, which makes it easier to create command line tools using Swift. And then we add the dependency to the CLI target, and we make a product. So by making this product an executable, what we will do is when we build this product, it will put an executable file out in the build system so we can grab it, share it, like send it to our friends, do whatever you want with it. So we need to write some code for that target again, right? So we've got a struct, we mark it as main so that we know it's the entry point. Then we import argument parser so we can make a little like command. We pass it an argument, so this is part of the argument parser. I'm gonna like skim through it, but you can look in more detail in the GitHub repo. And yeah, you pass it an argument, which will be the path to the Markdown file. Same thing as a script did. We want to get that functionality back. And we just make a run function, which is where the code will execute. So this run function will already look very familiar. So we do some file manager stuff to get the contents for that path that the user provided. Then we import our library, reading time, and we do some calculation. So this time it's just reading time.calculate. So we've absorbed all of that logic of removing emojis, all that sort of stuff is now in a separate package. And we use a date formatter in this case just to print minutes and seconds, and we just print it. And that's it. We've got an executable. But now the fun part begins, which is to build this executable, right? So for macOS, it's very, very straightforward. You just do Swift build. You pass it a configuration if you want. In this case, it's going to be release. And in this case, I'm specifying a product because I'm going to have a lot of targets and a lot of products. So I want to make sure I only build this. And I think it's something Antoine mentioned earlier. The limitation is that running Swift build is going to download everything, all the dependencies that I have. But if I specify Swift build as a release, even though it checks out all the dependencies in my project, it will only build the ones that, for the reading time CLI project. So I can do that. I'm cheating a bit. There's things cached here in this video, so it takes only 40 seconds. Probably would take more. And then you can see there's a file in .build release reading time CLI. That's an executable that you can just run, and yeah, it works. You've got an executable. But that's only for macOS. So you need to make it available. I didn't really need to. Like all of this is because I wanted to make it available for Ubuntu. So how do we do this? Well, it's not as easy as the macOS compilation, and there's some options, as Tim talked about yesterday. You can use Docker containers. If you've got an Ubuntu machine, you can use that. You could use GitHub Actions. But I chose to use, because I wanted to learn more about this, because I'm really interested in compilers, I chose to use cross-compilation. So the easiest way to understand cross-compilation is that you're running, so you've got two concepts. One is a host and one is a target. So the host is the computer or operating system where you're building, and the target is what you're building for. So you're building for Linux, for Ubuntu in this case, but you're building on macOS. And to do this, the Swift team did some awesome work to add support for this by passing in a destination.json. So this is a JSON file that basically has a bunch of things. So it's got an SDK, which will be the Ubuntu SDK, a target, which will be the architecture triple that you're targeting. So it will be Linux, x86, 64, or ARM64, whatever you're targeting. But the thing with this is that you need the target and the SDK and everything to be installed in your system for you to point to a specific directory, right? And the pro tip is don't do all of this yourself, because there's people who have gone through this pain already and can really, really help you with this. So something I found while I was really, really struggling and trying to copy code from one of Swift's repo was this tool by Kismiley, and it's called SwiftPM Linux Cross. What it does, it's available through Homebrew, and it installs all the required SDKs for an Ubuntu version and a Swift version. It also creates a destination.json for you. So it already has figured out where all those paths that it's downloaded are, and it puts them in the right file. It gives you a Swift build command as well that you can just copy paste. So you run it, it gives you a Swift build command, you put it in your project, run it, and you've got an executable for Ubuntu. And something to bear in mind is that the version of Swift that you use for the toolchains that you download must match the one that you're building your project with. Otherwise, you're going to run into a lot of issues. You're not going to be able to compile. It might take a while to figure out why, but it's on the README for this project, so make sure you check that out. So yeah, how do you run this? So you install it through Homebrew, you call setup swiftpm toolchain, you pass it an Ubuntu release. In this case, it's going to be Focal. You pass it an architecture, ARM64, and a Swift version, 5.6.2. It's really, really as easy as that. Like, that's all you have to do. And then it will create a bunch of directories. So it'll create a toolchain, Focal, ARM64, 5.6.2 in this case, with 2 destinations, which is what you have to pass to Swift build, and a bunch of packages and things that the destination files need. And then it gives you 2 commands as well, so you don't really have to worry about it. You can just put those commands into your project, run them from the command line, and your project will build. You'll have an executable for Ubuntu. Chances are, the first time you're not going to have an executable for Ubuntu. Things are probably going to go wrong. So some APIs are not available in all toolchains, and I really struggled with this. And at this point, I was very discouraged, but don't be discouraged because there's ways to get around it. So compiler directives, so you remember when Tim was putting that ifOS Linux thing yesterday, you can use compiler directives to help you with this. So this is the code that I used to count the words in a string. So what it does is it uses the enumerate substrings method from string, and it uses the bywords option. Now, for some reason, bywords is only available in the Apple ecosystem. It's not available outside of it. So what I had to do is provide an alternative implementation. So what I did was, if the OS is not Linux, then provide a slightly different implementation using character sets. It's not ideal because it doesn't account for certain languages, but it did the job. If anyone has a better approach like that I can do, then yeah, please let me know. Again, the Windows build I'm going to do next, it faces the same exact issues, so I'm not going to go through them. And if you want to learn a bit more about this topic, I have an article going in my blog going a bit more in depth about it. Don't worry if you don't want to scan this now. I'm going to go quite quickly, but I'll share the slides afterwards. So next up is compiling for Windows, because we all love Windows, right? So yeah, let's do this. And it was a lot more difficult because Docker and cross compilations did not really work for me. I had to set up too many like virtual machines and stuff, so I decided to kind of like give up on that until I found out this GitHub action by Salim Abdul Rasul, who is basically the driving force of Swift on Windows. And it's called GHA Setup Swift. So what this allowed me was to create a workflow on GitHub Actions that run on a Windows machine. It sets up all the Swift Windows toolchain for you, so you don't really have to do anything. And then all you have to do is run, as we did before, you run Swift build on it, and boom, you've got a Windows executable. Only that, again, it's probably, again, don't do it yourself, pro tip of the session. And yeah, it wasn't as simple as that. So that's something I tweeted in absolute frustration at the GitHub Actions failing for a while. You're gonna probably struggle with certain things. One of the things I struggle with is that because Swift Package Manager checks everything out, all the dependencies, there's a bug in Git on Windows where you can't have colons in your path, and Danger had like certain colons, which was one of the dependencies I was using. But yeah, got around it, finally got it working, and I got an executable for Windows as well. So we made a cross-platform executable just using Swift as well. And then a bit of timely news as well. I added this slide over the weekend, so bear with me if I struggle a bit with this. But the browser company, I don't know if anyone's used Arc before. It's a new browser, but they've announced that Arc is it's macOS only at the moment and written in Swift, but they've announced that it's going to be available on Windows next year. And you might be wondering, why the hell are you telling us this? And the reason I'm saying this is because they decided to share the same code base and use Swift for Windows for their Windows build, which is pretty incredible. And you have to bear in mind, as Tim said, there's no Xcode, there's no actually async await, there's no instruments either, so they're taking a stab and a big risk And I think the co-founder said that it's like a 60% chance that it will succeed. But they've taken a step and they're working together with like Salim Abdul Rasul as well to kind of, improve the ecosystem and maybe provide like a way of building cross-platforms app with Swift, which I think is amazing. And yeah, it provides a great opportunity for the community because I think they mentioned, don't know if they will do it eventually, but they mentioned they will eventually open source the code, which is, amazing for us. So there we go. We've got 3 executables. So where else can we take our little library? Where else can we take it? So let's create an API, right? So what if we don't want to make an app or have an executable? What if we just want to make a request and get an API? We're going to use AWS Lambdas for it. And again, monorepo, we're going to create a new target. So this target is going to be an executable, just like the one we had before. This time it's going to be a reading time Lambda. We're going to have to bring a dependency from the Swift server repo called Swift AWS Lambda runtime. And this gives you access to 2 things. One is the Lambda runtime, where you're going to write the Swift code to handle any actions that your Lambda takes. And you're going to have access to the AWS Lambda events. So Lambdas are triggered by events. So in this case, I'm putting an API gateway in front of my Lambda. So every time the gateway gets called on a specific route, the Lambda is going to wake up, it's going to run some Swift code, it's going to give us something back. And then obviously we're using reading time because that's our core feature. And yeah, we're just going to be using that to calculate whatever we need. So let's just run the Lambda. It's literally as simple as that with a few missing imports. You just need to call lambda.run. You get a request, in this case from API gateway, and you've got a callback. It's an asynchronous operation. You just have to return it. You have to call callback with success or failure. So what you do in this case, I guard that the method is posed in the request and that I'm going through the right path. Then I decode it. This is simple, like decodable stuff. I make sure that there's a content in the request and that I'm getting a string. I add some error handling so I can call back with bad request if it doesn't work. And the next thing I do, I finally call reading time. So from the request content, I want to calculate how long it would take to read that. And then I just return it as a string, as a JSON string. That's literally all it takes to make a Lambda. But then you have to get to the hard part, and the AWS console is a bit hard to decode sometimes and to understand. But just an overview, there's a Lambda there, there's the API gateway. Every time you call a specific route on the API gateway, the Lambda is going to wake up with some content that you've passed into that route. So to build an executable for that platform, for Amazon Linux, Apple provides us some Docker images, so we can do a Docker run, and we can do the same exact thing we've been doing. So just Swift build the product, which is the reading time Lambda, and that will generate an executable and a bunch of other files that it needs for the Lambda. And in this case, I'm just gonna call a script that was I found in the Swift server repo, and it just packages everything into a zip file that then you can upload to your Lambda, and that's it. You've got a working API, all written in Swift as well, and in the same package that you had your initial library. So let's go to our network client, and we call the endpoint. So this is the domain that AWS gives you. Didn't want to spend any money, so I didn't really buy a domain. So I call calculate on it. I pass it some content. So the content is a markdown string. This is one of my blogs. And then what it does is it reads. It gets the average time it takes to read. And then it returns me an OK response, with the time that it takes, 319 seconds. And that's it. You've got an API. So moving on, what if you don't want to have it online? What if you don't want to make online requests and you just want to run a little server, spin up a little server on your computer that you can run the API on and type and say calculate, and you can build a little website with it. So let's make an online playground. I'm going to use Vapor, and I'm going to use Plot. I could have used Vapor's template engine, which is called Leaf, but I wanted to do it in Swift, so I just used Plot, which is what Daniela talked about yesterday as well, which makes it easy to write HTML with Swift. So how do we do this? We go back to our repo, to our Package.swift, and we add a new target. Before we do that, we add a package, we add Vapor, and we add Plot. That's the 2 dependencies we need. And we add a target first, which is the reading time side with Vapor and Plot as products, and then reading time as well, because that's going to have to perform some logic. So this will be the core of the server, so this will be the site itself. And then we add a little executable target, which will be the runner. So we need to run the server somehow. All of this is explained in the Vapor docs and the Get Started guides. So make sure to check it out if you want to learn about Vapor. And then we have to write some code, right? So I've very much simplified the Vapor application here. But the main point is that you have a roots function, and you have to define some roots, like Tim did yesterday. So here I define a get endpoint at the root of my application, at the domain. And then I return some HTML. So I do this using plot. So you can see that the return type is HTML, and it's a type, it's a Swift type. So then I have a head, which will have a title and some style sheets. And I have a body. So what you would do in HTML, right, by using Swift. This body will have a div, like a container div. Then we have some bunch of other elements. And then finally, we have a form. So this form, I want users to input some Markdown text and then hit a button, submit the form, and then I'll be able to tell them how long it would take to read that Markdown. So this form will be of method post. So what this means is that every time you submit the form, it will make a post request to the same endpoint of your server. And then we have the text area where the user is going to input some code. We have another bit of text that I'll get into in a second. And then we've got the submit button. So it's a button of type submit. That's all it takes. And you end up with this, right? So yeah, here's me writing some code in a fake live demo. It's a video. So yeah, it supports emojis and everything. You calculate reading time, and everything goes horribly wrong. So just like a live demo, right? So yeah, you get an error with a reason of not found. So the reason for this is that I said that it's going to make a post request, right? And we've not handled that. So the application needs to have a post request. So this post request is going to get some content that the user typed in. We're going to just decode it using codable types. Then we're going to call calculate again, on our lovely reading time library. We're going to pass it the content from the form data. Then we're going to create a query parameter, and we're just going to redirect to the root of our domain. So the reason we do this is we just do the processing in this post bit, and then we just go back to the get endpoint so we can display how long it took to read that content. So now we go back to the get endpoint, the one that we wrote earlier, and we can just now get the query parameter. I really like this because I've worked with JavaScript for a bit, and it's a bit of a mess to use query parameters and get them, and it's always like a mess with types. But here you can, it's as if it was like decodable, right? So you can get query.get a string at that bit at reading time, name of the query parameter. And then the good thing about plot as well is that you can do a .if, which is quite nice. So you can say only show that element if reading time is not nil, right? So you can say show me H3 with this estimated reading time, blah, if it's got like a query parameter. So we can see we get into that domain again. We enter our Markdown, and it tells me, the reading time is 2 seconds. So that's it. We've built a website using Swift as well. So what else can we do? I really wanted to turn it up a notch here as well. And yeah, just want to show you that you can actually take it even further, and you can call Swift from JavaScript. So let's consider you've got a HTML file, right? So you've got a text area. It looks exactly the same as our one before, without a form in this case. And you've got a button as well. So we want to do something when the user presses on that button. So how are we going to do this? So WebAssembly is the key. So basically, WebAssembly is a binary format which is compatible with web technologies. It provides a very easy compilation format so that you can go from languages such as Swift, Go, Rust into something that web technologies can understand. It produces a .wasm file, and wasm files can be imported from JavaScript, and they do actually have great support across all modern browsers. And you can see this is a screenshot from Can I Use, which is a website that tells you certain APIs and CSS selectors and stuff. Tells you how well supported they are across different browsers. And you can see that all modern browsers actually support it and have for a long time. And it does say that for 96%, 96.18% of users that use a browser will be able to use these APIs. So, we're kind of safe to use this. So let's do it. So how do we actually compile Swift to WebAssembly? So we can use Swift wasm. So Swift wasm is an open source project which provides a set of tools to compile Swift to wasm. It's got a forked Swift toolchain to add WASM compatibility. So you don't need to use any of the tools. You could just download the Swift WASM toolchain and build your executables to WASM. Yeah, and as I said, executables targets can be built to produce WASM binaries. And there's a lot to kind of like understand on how to expose things to JavaScript. You need to use like certain attributes and things called, I think there's an attribute called C declarations as well to make functions and variables available to JavaScript. But there is an amazing book, and it's completely free at book.swiftwasm.org. So make sure you check that out if you're like me and you're curious about these kind of things. So I'm going to be using something, I'm going to cheat a bit. I'm going to be using something that's already there. So I'm going to be using JavascriptKit. So again, it's part of the Swift WASM organization, and it allows you to interact with JavaScript through WebAssembly and Swift. So what I'm going to do as well is I'm going to make use of the carton executable, which is also provided by Swift WASM, to compile my executable into a WASM binary and create any glue code, any JavaScript glue code that I need to import my binary into my application. And yeah, the other magic thing that you can do with JavaScriptKit is you can read the values from vanilla JavaScript and from Swift. So basically, we're going to see that in a second. But first, let's get back to our Package.swift. So as you will have guessed by now, we need to create another target. So it's going to be an executable target called reading time WASM. This is going to take in a single dependency, external dependency, which is going to be JavaScriptKit. So we just add it to the dependencies array. And we import reading time as well, because we can, basically use the same library we've been using all along. And then we define an executable product so that Carton can find it, and it can generate the WASM binary from it, and it can do all the magic that happens behind the scenes with Swift WASM. So we can write some code. So we import JavaScript, we import reading time, and then it freaked me out when I saw it. It will look exactly like JavaScript, but trust me, it is Swift. I'm not cheating. You can look at the code on my repo, and you can run it yourself. So yeah, you can get the document, like the JavaScript document. You can do a query selector and get the button element, the HTML element from an ID. Then you can pass it a non-click, right? So standard JavaScript. In this case, you have to provide the JS closure, which is a JavaScriptKit type. You get another element. In this case, you get the text area. You can read the text from it. You can call, reading time.calculate for that text. And in this case, I'm not going to do some further manipulation because I kind of run out of time at that point. So I'm just going to print it to console. So you just print the seconds that it took to read that content. And then you just return null. I'm not too sure what this is for, but I think you can do some extra side effects in JS closures. I didn't need to do anything for this, so just return null. And we can, basically you just bundle it together. It will create, using Carton, it will create all the glue code. It will create all the JavaScript you need to import it into the application. I tried to do this manually. I finally got around it, but you will have to deal with, like, if you want to pass a type that's like a string, for example, you will have to deal with like memory buffers and stuff like that. So I would recommend, if you can, try use Carton because it makes things a lot easier to compile to WASM. And then we specify the product. So this is kind of the same we've been doing, right? Swift build with a product because it's a monorepo. We want to make sure we only build that. And then this will generate a lovely WASM file with a hashed name, JavaScript file containing all the glue code, and then some JavaScript resources that it needs to obtain, like the document and stuff, so that we can focus on writing Swift code. And yeah, this is what it looks like. So I've got some markdown content, and then I hit calculate, and it prints the seconds it takes. A bit lazy that I only printed it in the console. I could have done the same with like a HTML element, but I just decided, it was a bit, I was a bit tight for time, so I just decided to print it to the console. I think I'm going to make it available on the repo. I'm just going to add the code and commit it so everyone can take a look. But yeah, that's about it. That's about all my talk. You can see on the right the structure of the code. So there's one single package that you can import and run your, command line tools, import the library, whatever you need. So yeah, let's recap what we've built. So we've started from a simple script for macOS. We've gone on to a library for all Apple platforms. And then we've built a command line tool for macOS, Windows, and Linux. So like a true cross-platform app that we can run in all platforms. We've built an API using AWS Lambdas, an online playground using Vapor and Plot, and a wasm binary which can be run on the web. And I did say anywhere that supports WebAssembly. It's not exactly true because I used JavascriptKit. But the point is you could technically, I don't know, run this Swift file in an Android phone, like if you compile to wasm, because I think Android Kotlin supports WebAssembly. So yeah, you could do all sorts of things. And yeah, before I go, I wanted to make my slides using this. So this is a library, a Swift package by Josh Holtz. What it basically allows you to do is to make presentations and slides from Xcode. So you can basically embed Swift UI components. You can do a bunch of like crazy things in there. So if you're doing a Swift UI presentation or something and you want live code, you can have components running there and interact with them and stuff. It is very, very cool. Because of the amount of slides, I think because of all the animations and stuff, I ended up with like 100 slides. So it was too much code for me to understand and keep track of. But I am intending to use it in a smaller presentation at some point. It's amazing. Check it out. And yeah, that's it. Say hi. And yeah, you can find me on Twitter. You can find me on my blog. I blog regularly at polpiella.dev. And I launched a newsletter not that long ago, the iOS CI newsletter. So if you want to keep up to date with the news from the community, every couple of weeks I send an email. No spam, I promise. So yeah, thank you very much for listening.
So do you take questions, Paul?
Absolutely.
Anyone have a question? I'm going to try and hit you.
Hello. Yeah.
Hello.
So Swift is quite powerful. It's almost like you don't need any other languages.
Was that the question or?
Yes.
Yeah, cool. I try to not need other languages. I'm gonna sound like a hypocrite here, but my site is written, like my personal blog is written with JavaScript entirely. But yeah, I've been trying to like explore as much as you can do, and I really think we are in a place. Obviously, if you wanna do a cross-platform UI, you probably can't at the moment, and it's gonna like, yeah, that's what the Arc people are trying to do at the moment. But yeah, it is very powerful, and it's getting somewhere very, very beautiful. I really like it.
Okay, thanks.
There was another question over there, the tall guy.
Got it. Perfect. Yeah, first of all, great talk. I believe it's your first time, isn't it?
First time, yeah.
Yeah, but very well done.
Thank you. Thank you.
Yeah, I couldn't tell, but I've got two difficult questions for you. That's always nice when you first
Awesome.
talk.
Yeah. But I can relax now. But
Yeah. No. When are you going to buy an Ajax jersey, and what is your favorite football T-shirt?
So
should I close the door?
If they've got a store at the airport, I will buy.
They have. Okay,
I am
check.
committed. I'm promising I'll buy an Ajax T-shirt today. And my favorite one that I've got, it's a Scotland T-shirt, like national team. So my girlfriend's Scottish, and she got me that for my birthday. And it was from like the 80s, I believe. It's like an orange, like third kit. It's very, very cool. But also Barca T-shirts, any Barca T-shirts. Big Barca fan. So,
But it will be the Ajax one after today, right?
If there's a store at the airport, I will. Yeah, I promise.
Thanks, man.
Okay, any other questions? Because they're still bringing in the soup. No pressure behind the curtain now. Nobody?
I got another one related to your talk.
Cool.
I'm actually curious because I know that Swiftland now comes with a binary target, allowing you to use it directly without building, which greatly improved the performance of our CI pipeline. Mm-hmm. But I believe Danger isn't possible to do that. And I wonder if you know why and whether it's something they just need to add, or is there any limitation?
I'm not entirely sure. Like I've got, I feel like it's one of the struggles of my like CI at work as well. Like when Danger has to run and it has to build, like it takes quite a lot of time.
Exactly, yeah.
For very, very simple things that you have to do. I'm not entirely sure. I think their setup is that you have to provide like a dynamic library, I believe, for a product that they basically tag all their binaries onto. Mm-hmm. So I'm not sure if that's the reason why, like they've not gone around it, but yeah, it's open source, right? So I guess we can
Yeah, let's
always
see if we
try.
can fix that.
Yeah, can always try and see.
Cool. Thanks. Is the soup ready?
Let's see. Yes. And thank you, Paul.